Question 3 is multiplying matrices. Now here we need to know a few basic rules about dimensions and how to multiply and everything. Multiplying matrices is very easy in calculator, and since we are just doing the MCQ part, stick to the calculator. Now here first thing is there are some rules for multiplying. Now you imagine you have a matrix that is A, B, C, D, and you have one more matrix E, F, G, and H. Now you want to multiply this. First thing you need to check what are the dimensions. This is 2 cross 2 and this is 2 cross 2. Even other dimensions can be multiplied, that doesn't matter. But the most important thing is the first matrix. Now this is matrix A and B. The first matrix columns must match the number of rows in the second matrix. Why? Because we use a method like this. We have to do like this and we multiply this. That is why the columns over here, how many? 2 columns and 2 rows must match. Now I'll give you another example. If I have A, B, C, D, E, F, and over here G, H, I, J, K, L, can I multiply them by each other? Absolutely, because over here it's 2 cross 3 and over here it's 3 cross 2. These two match. That's why I can multiply this by this. Okay. Now, why I'm telling you this is important. There's one problem in this topic. I guess you need to know this multiplication, basic stuff. So what happens over here is I'll just multiply right side over here. So the first one towards the tail has to be multiplied to the tail of the next matrix in its first row, first column. Sorry. See, now the thing is, this row is being multiplied with this column. Okay, but the column and the rows must match, because see, this is 1, 2, 1, 2. Now A multiplied with E plus, what about this B and G? You multiply it with each other. That is what happens with the new element. Now when you solve this, you get the answer. What about the next thing? Same row with the next column. So it'll be over here, leave some space, it'll be AF plus BH. Now similarly, you can solve the others. It'll be C and E now. CE plus DG, and lastly we have CF plus DH. Now if you see, there are various similarities. Now you can see over here A was the first one. In the next row it becomes C, but E and E remains, G and G remains. This changes. Whereas over here it's A and C, again F and F, H and H remains same. Now what about this problem over here? It's the same thing. See, A with G. So it'll be AG plus BI plus CK. And this again will be multiplied with the next one. So it'll be AH plus BJ plus CEL. My handwriting is a bit problematic, but I hope you understand it's JKL. They're in order. Now next one, D with G. So it's DG plus EI plus FK. It's almost done. And now we have DH plus EJ plus FL. Now this is the answer. But now look over here. What happened? Here we have 2 cross 2 matrix. Over here also we have 2 cross 2 in the final answer, right? If you solve this up, you'll get one over here, one value, 1, 1. Even over here it's 2 cross 2. How is that? The dimensions occur based on what are the dimensions of the original matrices. The resultant dimensions are this and this. What are they? 2 and 2. So it's 2 and 2. Now here also it's 2 and 2. Now imagine you had 4 cross 6 and 6 cross 5. Then this matches. Yes, you can multiply, but the resultant matrix would be having 4 cross 5. This is the answer. So this is the rules you must know. These are the basic rules. I told you other rules also not related to the problem. But now we'll come back to this problem here. If the product of matrix A and B multiplied is given over here, let's write it as AB, has the dimensions 5 cross 8. The dimensions of the final matrix is 5 cross 8. The dimension of A is how much? 5 cross 6. What is this dimension? Now we can easily interpolate it. Now we know this matrix, in order to be multiplied, must match over here. This columns must match with the row. So obviously it's 6 over here. Multiplied with this, and the last over here will be the resultant matrix, right? It is 5. And what is the next one? 8. So it must be 8 over here. So they must match. So this is the answer. It's 6 cross 8. As simple as that. I hope that's clear. Oh, we finally reached this problem. Now, this is one of the problem why I have trust issues with exams. Because we have an MCQ question and we have to do all this. So now this is just for general knowledge, I guess. I mean, not general knowledge, for your exam knowledge, but I'm sure this may not be asked in the exam. Or you just have to write these sentences. I'll tell you what needs to be done. They're asking you to prove all these properties. And mind you, there will be 4 options, so you need to just select the correct option. So I'm not going to go through all this. It's scalar distributive property. I'm sure you might have gone through this in the class. All it says is, if you multiply a scalar to, sum of 2 matrices are there, and you multiply a constant value, say 3. This is equivalent to 3a plus 3b in matrices as well. You can take any 2 random values and check. You can take some numbers also and you can check. See over here, they are doing the same thing. Ultimately over here, C times A is CA plus CB. That is what you're getting. So this is called scalar distribution property, because when a scalar is multiplied, you can multiply to each of the matrices. Now the next one is matrix distributive property. What it means is there's the same thing, but you have a matrix now. Now this really works even with matrix. A scalar, it's easy, right? It's just number you're multiplying. Imagine, it is very obvious, okay? So it's 3b, yes. Now even if you multiply a matrix, it happens. So you just add this up and then you multiply these matrices. See, matrix multiplication, you do that. And then ultimately you're going to get what you know. You're going to get, say, imagine I write matrix C times A plus B. This is going to be similar to the scalar distributive property. The distributive property works even over here. It will be CA plus CB. This is the rule, second rule. Just remember this. And even over here, you can do the other way around, because if you multiply it from this right side, right, even then it's the same thing. It'll be AB plus BC. I'm sure they're not going to ask to solve any of this, just to choose. And now what about associative property? Associative property also works. So you can multiply, see now for example, AB and then multiply, first you multiply AB and then multiply C, or you multiply A later, first multiply B and C. Absolutely fine, you will get the answers. Now finally, the last property, that is the associative property of scalar multiplication. I'll tell you this one as well. This is the last one. I'll write it over here. See, if you have a scalar multiplication, okay, it's about multiplication, you have A and B. Which do you multiply it with? Do you multiply the scalar with A and then you multiply? It's fine. Or even this works like this. You just, not this. What I'll do is I'll leave A out and I'll multiply the scalar with B and then multiply AB. That's also fine. That also works. Okay, it's not easily visible, but this is the answers. So that also works. Okay, so you can see it's A times CB, and over here it is CA times B. So that's about the properties of multiplication. I hope that's clear. Now moving to the question 48, it's open-ended one. Write 2 matrices AB such that AB is equal to BA. Now I've seen the answer a while ago. Any matrices which are all the same elements, that works out. But actually the method is, which came to my mind, is inverse. There is a rule that if you have 2 inverses, like A, and inverse of this, A inverse, will always be equal to identity matrix. So now inverse is -1, times A will also be identity matrix. If you multiply 2 matrices, say AB, and then they are equal to BA, then they are inverse of each other. But then I saw the solution set and I realized, even if all the elements are same, if you have say 1 1, I did with other values also, 1 1 1 2 2 2, what happens is you will get the same thing. I'll show you. Let's do it in the calculator now. Let us go to mode, then 6, and let's fill in the matrix 1. as 5 cross 5. You can even go 2 cross 2 I'm selecting, but you can even go 3 cross 3. But you're just gonna put in more values and stuff. Just take 2 cross 2 whenever it's fine. So now I will choose 4 4 4 4. Okay, that is saved. I'll press AC, go press shift, mode, sorry, 4, and now dimensions of the second matrix, and that is option 5. Now here I will choose 5 5 5 5. Now press AC. Now let me do the multiplication of matrix A multiplied by matrix B. That is option 4. What is the answer? It's 40 40 40. Now let me do the same thing with matrix B multiplied with matrix A. It's again 40 40 40. So this will work with all the answers which are having the same elements. That's the thing. Now, over here the answer showed up, but how do we solve it? The answers are not over here anywhere in the matrix. I mean, it's not direct. So what happens is, you can see there's a matrix multiplied with other matrix and the solution is given. This means you need to do the first step of multiplication. You need to multiply this with this. It becomes A times 4 plus B times 2 is equal to what? This and this. This is the unit element 10. Now here we can't just solve here. There are two variables. So again, let's multiply this with the next row, and what's the answer? It's 11, right? So now we will have A times 3 plus B times 5 is equal to what? 11. Now you have simultaneous equations. And I'll write this also over here and over here. I'll write the constants first. 4c plus 3d is equal to 20, and we have 2c plus 5d is equal to 29. Now let us take our calculators. No going to matrices or anything. All you need to do is go to mode, equations, that is option 5, and this is how many variables? Two variables, simultaneous equation, that is option number 1. And now type in the coefficients. This is 4 for A, 2 for B, and 10. Similarly, we have 3 over here, that is 3, 5, and 11. What are the answers? A value is 2, X is the first one, A I considered, B is 1. Same way you can do it over here. Before going to the second one, I just realized that I've written it wrong. Coefficient is 4C times 2D. And then we have 3 over here. I don't know, I was sleeping, I guess. 3C times 5D. Okay, that's huge errors. Please don't do the errors like what I did just now. Please be vigilant when you're typing in the calculator or writing it down. So now let's type in the values. It'll be 4. Over here it is 4. Then next coefficient is 2. Then we have 20. And we have 3, 5, and 29. And what are the answers? 3 and 4. This is how we can easily solve A, B, and C values. So please be careful when you're multiplied accurately. A becomes multiplies with B, B with 2, A with C, B with 5. And remember the answers. The first element, the second element, and down will be the below second row. Because you're taking CD from second row, the answers will be the second row. Second row with first column will be 2, 1, and so on. Okay, we have one last to go. Feels like it's never going to end, right? Writing in math. So use the data on Lisa Leslie found at the beginning of the lesson to explain how matrices can be used in sports statistics. Describe a matrix that represents the total number of points she has scored during her career, and an example of a sport in which different point values are used in scoring. The table shows a scoring summary for Lisa Leslie. Over here they have given the values. Now, okay, there's an important thing to know. High scoring of baskets. Okay, the point values for each type of basket can be organized. Okay, from here. Now, what you need to do is total points scored in the entire season. So I'll just explain what they have given you. They have given you this table. They have told these are the scores by in a regular season. In this year, see 2005, 6, 7, 8, 2005, 6, 8, 9. So this is the player. This player has scored field goals, so many. 3-point field goals, so many. And free throws, so many over here. And the points for each of this type, for field goal is 2 points. Whereas 3-point field goal is 3 points. So 7 into 3. And free throws is 1. I use matrix multiplication to find the total points scored during each season. Now this can be easily done by matrix multiplication. Okay, you know what are the points, right? It's 2, 3, and 1. So this must be multiplied with 2, this with 3, and this with 1, and then you get the answers. But here there is one other thing. If you start multiplying like this, it's just not possible. The dimensions do not match, right? So how would you multiply? You need to take p here. So it'll be 1, sorry, it'll be 2, 3, and 1. Now you can multiply them. Now, if you're getting confused with this, one easy way is try multiplying this. It's not possible. There are 4 columns and there's only 1 row. It's not possible. Whereas if you do the other way around, you have 3 rows and 3 columns and 3 rows. Yes, it's possible. So it is basically 1 cross 3, and over here it is 3 cross 1. Sorry, 4. So yes, it is possible as long as those two match, but this must be over here before it. The other way, without any multiplication or anything, you can also do it. All you need to do is add them all up over here, these. Add them up and multiply it with 2 because that's 2 points. Add these up. We have done similar problem in the question 1, and these multiply with 3 and add them up. Now here you will get the total points throughout all the seasons. I just realized over here, what did they ask? During each season. If they ask all the points together, you just do this. You know what I just wrote. But now since they have asked each season, what you need to do is multiply this by 3, multiply this by 2, multiply this by 1, add them up. Add them all up. That is your season 2005 season. Same way, multiply this by 2, 2 is this, 3 is this, and 1, and add them up. So this is how we do it for each season. But the simplest way is this multiplied by this, but if you're getting confused, you can even do it in calculator by adding it up. And let's look into the answers. And over here, they have not, multiplied. They have just explained. They just wanted you to know what exactly has been done. So this is how it is. But generally, in your exam, you will get direct problems. They're not gonna, tell you to, analyze this and this, that, and all. You will have 4 options. So all you need to do is multiply. So this problem can be done by multiplication, by matrix P multiplied with the B, or just multiply over here directly. The field goal is 2 points, 3 point is 3 points, and lastly, free throw is 1 point. Add them up for each season. If you want the total, as I told you just a while ago, everything must be added, multiplied with 2, 3, and 1. So that's the end of this topic. A lengthy one. Stick to the questions which are pretty straightforward. They might ask you simple ones. So understand how to use the matrix multiplication calculator, just the multiplication of rows and columns, and then you can easily solve these problems.